Push that rock with Simpson math. One of the most confusing things that happens early in trig class is this idea of coterminal angles. We define this idea of an angle in standard position. An angle in standard position is one that has a vertex at the origin of a Cartesian plane. It has an initial side on the positive x-axis that stays here, and then we have this idea of rotation. So the other ray of the angle is right here, and if it stays here, then we call this a 0-degree angle. But if it rotates around and then terminates somewhere, wherever it terminates, we call that the terminal side. So, here, let's make a 120-degree angle here. So I'm going to aim for that point in space out there. So this is a 120-degree angle here. So theta equals 120 degrees. And if we wanted to switch to radians, we'd need to know this arc length right here, and then this radius, and we would take this length and divide by that radius, and we'd have the radian measure of that angle. But what I want to talk about here is this idea of coterminal angles. One angle is this other arc that's here. Okay, how many degrees is that? Well, if this is 120 and there's 360 full in a circle, then this going from here to here is the other 240 degrees. 240 plus 120 making 360. But this angle here, we think of it as rotating, instead of going this way, counterclockwise, we think of it as clockwise rotation, rotating around to here. And we call that, when it's clockwise rotation, we call it a negative. So we would say this angle, this theta, or maybe I should use another symbol, let's use lambda. This angle is negative 240 degrees. Now notice, it terminated at the same place, and that's the idea of coterminal angles. The definition of coterminal angles are two angles in standard position that terminate at the same intersection point of the circle that they intersect, that's centered at the origin. So if they terminate in the same location, they're coterminal. And so this angle here that starts here and rotates clockwise direction 240 degrees, we call that a negative 240 degrees. It is coterminal with the angle that rotates counterclockwise 120 degrees. Those are both coterminal. And of course, this idea of rotation gives us the ability to rotate around more than once. So I could rotate past the 120, go all the way around 360 degrees, then go another 120, so that gets me to 480, and call that terminate there. So that's a new angle. The way we typically symbolize that is we have our pen go around like so, and then go like so. And we say, oh, there's a new angle. Let's call this one, I don't know, I'm running out of Greek letters that I know. My Greek is not so good. Let's see, there's a beta. Okay, and we could say that's 480 degrees. So it's a angle, a rotation all the way around the circle plus another 120 degrees. Well, since it's plus that other 120, it terminates in the same location as 120. They're not the same angle. One is a full rotation plus some. The other one is just a partial rotation. So they're not the same angle, but they're coterminal. So that's a pretty confusing idea that happens to us early in pre-calculus, and you'll have to try to get your mind wrapped around it. One more definition before I go, and that would be quadrantal angles. Quadrantal angles. And those are just angles that terminate on one of the axes. So they always start here. The initial side is always here. But if I rotate and stop here, then it's quadrantal. That would be 90 degrees. If I rotate all the way over here and make a straight angle, 180 degrees, well, that's quadrantal because I landed on the axis. So if you terminate on an axis, then you're a quadrantal angle. Math made simple. Simpson math.